So now see here the graph for y is equal to f of x is equal to cos x. So earlier we have seen the graph for sin of x. It is like same wise we are having the graph for cos x. But we have to find here the inverse of cos x. Okay. So that's why we have drawn this graph. So what are the domain of cos x? See here, what are the domain of cos x? Cos x domain is cos x mapping is here from R to here. Why we are taking R? Because on the x axis we are having all the real number. That's why we are taking the domain is the nothing but x values, and x on x axis we are having all real numbers, positive and negative. So we have taken domain as R. And what about range? Range here. This graph is lying between +1 and -1 on y-axis. So it will not go beyond +1 or -1. It lies in between. So it is continue like this. Continue on plus axis it is goes continues to plus infinity. Here it is goes continues. It will goes continues to minus infinity, but it will not go beyond plus or minus of y-axis, plus or -1 of y-axis. That's why we are taking these ranges +1 to -1, and these two are including plus and -1 values are including. So it is a closed interval. So you can see that we have to find the inverse of cos x. So to find the inverse of cos x, we have already discussed the function must be 1, 1 and onto. So see here, this function is not 1, 1. Why? On multiple values of, see, on the 0 we are having 1 value, on 2 pi we are having 1, value 1. On -2 pi also we are having +1 value. Okay. So, or you can write in this way. I think it will be easy for you to understand. Here domain and range cos x mapping like this. So we are having 1 on 0, on 2 pi and on -2 pi. We are having 1 value. Okay, like this. And for 0, you can see 0 is on pi, -pi, and also like this continues. So for 0 also we are having two values on x-axis, pi and -pi. So you all know that a function is, it will not form a function because here we are having three values on the first set, or the three values having same image. So it will not form a function. Every value will have different image, then it will form a function. So it is not a one function. Okay. So you can say it is a, sorry, it is a not a one function because everyone has same values, but it is a many one function because the many elements will are having same image. So it is a many one function. It will not form a one function. Okay, but it is an onto function. Why? For every value of on the y-axis, we are having one pre-image in the x values. So it is a onto function, but it will not a one function. So to find the inverse of this function, we have to make this function 1, 1. How to make? Again, like we have restrictions, impose some restriction to range and domain volume, the finding the inverse of sin x. Likewise, we will impose some restriction to range and domain values. Okay. So we will choose some values for which this function become 1, 1. We will restricted some values of range and domain so that this function will become 1, 1. After that we can easily find the inverse of this function. Okay. So see here, we will choose one interval. Which one? In this, here we are choosing one interval 0 to pi. Okay. So here I am choosing the value of 0 to 5. Choose one function which is from 0 to pi. I am highlighting this like this. It will be easy for you to understand by using that marker. So, select one interval 0 to pi to make this function 1 1. Likewise, we restricted to range values also, which is from plus 1 to minus 1. Okay, after taking the inverse of this function, the x-axis we are having plus 1 minus 1 values and the y-axis we are having real numbers. That means, see here, cos x is from this domain is real number we are having, and range is minus 1 to 1. Okay, for cos inverse the mapping is like this, from minus 1 1 to real number. So here range is r and the domain is the real number and range is plus 1 to minus 1 to plus 1. But for cos x it will switch like this here. Okay, these values is minus 1 1 is domain and range is r. But again we have, so you know that we have imposed some restriction to the this range value. We have imposed some restriction to this range value. Okay, so the cos inverse of x become minus pi to plus pi, sorry, 0 to pi. So for 0 to pi we make this function 1 1. Okay, you can see for remaining other values also we can take the function will become, this function will, for another values also this function become 1 1. Which value you can take here from this to this, from 0 to pi, after pi to 2 pi here, and here 0 to minus pi. Okay, also you can take these values, but this is the principal value branch. According to the rule, we have to take just this value. This is the principal value branch. Okay, so for finding cos inverse of x, we should have to take always 0 to pi. Okay, so we can take another value for the another values also, like this, from 0 to minus pi, or you can take minus pi to minus 2 pi. For these values also the function will become 1 1, but according to the rule we have to take only 0 to pi, so that here we have made some restriction to make this function 1 1 to find the cos inverse of x. So the range is minus 1 to 1 and the domain is minus 1 to 1 and range is 0 to pi. Okay, see here it is very simple. For the cos x we are having range is the x values is real numbers, and domain is x values, and x values are all real numbers, and the range is plus 1 to minus 1. Why we are taking plus 1 minus 1? Because these graph lies in between plus 1 minus 1 values. That's why we have taken plus and minus 1 as the range in domain, range values. Okay, so it will not, this graph will not go beyond the plus 1 and the minus 1 values. So it is not a 1 1 function, as you can see. On 0 we are having value 1, on 2 pi we are having value 1 same, and for minus 2 pi we are having same values. Okay, and means it is getting, this graph is getting multiple times 0 values, so it will not form a 1 1 function. So to make this function 1 1, we impose some restriction to the range and domain values. We select an interval 0 to pi. For this value the function will become 1 1, and the range is restricted to, range also restricted to minus 1 and 1, close interval minus 1 and 1. For this value the function become 1 1. Okay, and 0 to pi is the principal value branch, or the principal value of the cos inverse of x. Okay, whenever you the question is given to you, find the cos inverse of x, then you should have to take this value. If the question is given to you like find the cos inverse in the range minus pi to minus 2 pi, okay, here pi to 2 pi, then you can take that value. Okay, but this is the according to rule, you have to take only. If it is not given particularly, then you have to consider these values 0 to pi, close interval 0 to pi. So first sign of x, we find the how to find the inverse of the sin x, and what is the principal value. In here cos x, how to find the inverse of cos x and the principal value. Okay, so remaining we are having remaining 4 we are having trigonometric ratio, tan x, cot x, cosecant, etc. of x. But drawing of each, plotting of each graph is not in your syllabus. So just you have to understood the sketches which is given to you. Okay. In the textbook also you are having remaining 4 trigonometric ratios. So now you can see graphical connection of the graph, graphical connection of a function and its inverse. Okay, how they are connected, a function and its inverse, how they are connected graphically, I will show you. See here, see here, here it is axis, x-axis, x dash axis, y and y dash axis. Okay, so consider a point pi by 2, minus pi by 2, here 1 and here minus 1. Okay, now the graph for sine of x is, the graph is like this. So the point is here, here the point is pi by 2 comma 1, here minus pi by 2 comma minus 1. This is the graph for sine of x. Okay. Now likewise you can see the graph for sine inverse of x. X dash, y dash. You can see the point on the x axis for sine x. The older point on y axis is 1 and minus 1 for sine x. For sine inverse of x, the older point for the y-axis becomes x-axis. Here it is plus 1, here it is minus 1, and the x-axis point becomes the point for y-axis. This pi by 2 and here is minus pi by 2. And the graph is like this. Sorry, here you will get, here you will get graph like this. Here the graph is like this for sine x. Okay, for sine inverse of x, you will get graph like this. Now the point will also change. The point pi by 2 and comma 1 is for sine x. Here you will get 1 on 1 you are having 1 on x axis you are having 0.1 and pi by 2 on y axis, and here minus 1 and minus pi by 2. So this is the graphical connection. Graphical connection of inverse and function and its connection of a function and its inverse. Okay, suppose what we are doing, and note that we are taking this graph according to the principal value only. Here for pi we are having range is minus 1 to 1 and domain is minus pi by 2 to pi by 2. Okay, for according to principal value we are drawing these two graphs for sine of x. So what happened here? The point is 1 comma minus 1 for y axis. These points become for plus 1 and minus 1. These 2 points, the points are interchanging. Nothing will change. The points are interchanging. If the points are interchanging, the graph is also will change. Okay. Suppose you are having x-axis, you are having a point, xy plane, you are having one point like a comma b. Okay. If you are drawing the same graph for y comma x plane, then the point will interchange like b comma I. Likewise, points are interchanged here. The point on y-axis we are having -1 and 1. It will replace by on x-axis for sin inverse of x 1 comma -1. And the point pi by 2 are and minus pi by 2 are on x-axis for sin x, and it will changes to it replaces to y and y axis for sin inverse of x. Okay. So if you are drawing these two graphs together on the same plane, then you will see these two graphs are mirror images of each other. Okay, then you can see these two graphs are mirror images of each other. Okay, so remaining you are having four graphs for tan x, cot x, cosecant, secant of x, which the figure is given to you. In the textbook also you can see the plotting of each graph is not compulsory in your syllabus. Just you have to understood. If you understood how to find the uh, function and its inverse and what are the principal values for those function, principal value for range and domain, then it is easy for you to understand the examples. Okay. Okay, with this I will stop. In the next class I will take examples on inverse trigonometric function. Okay. Okay, thank you. Jazakallah khair.